Hi everyone and welcome to Smart Culture Education. This is the place where we make learning simple, clear and engaging. If you're new here, don't forget to subscribe so you can join us on this journey of mastering maths, science and more.
Question 5. A student uses a motion sensor connected to a laptop to investigate the motion of a hollow ball of mass 1.5 times 10 to the power of negative 2 kilograms falling through the air. The ball is dropped from rest. So that means the initial velocity is equal to 0. It reaches terminal velocity before it reaches the ground. The upthrust on the ball is negligible. Explain briefly why the acceleration of the ball decreases with time, part 1, and is 9.8 meters per second squared initially. In part A, they asked, we have to explain why the acceleration of the ball decreases with time. Now we know that the air resistance or the drag increases with speed. Hence, the resultant or accelerating force decreases. And in part 2, we had to explain why the acceleration of the ball is 9.8 meters per second squared initially. Now, we know that air resistance is initially 0, or you could have said that the weight or the gravitational force is the only force acting on it. Let's have a look at question B. The variation with time t of the velocity v of the ball as it falls towards the ground is shown in this figure. Part 1. Determine the magnitude of the acceleration of the ball at 0.25 seconds. Part 2. Calculate the resultant force acting on the ball at 0.25 seconds. Now remember, I'm just going to write down the important information. The mass of the ball is given. It's 1.5 times 10 to the power of negative 2 kilograms. Okay, so that is actually 0.015 kilograms. Okay, so what we have to do, I'm just going to read part A again. We have to use this graph to determine the magnitude of the acceleration of the ball at 0.25 seconds. Okay, so what I'm going to do is this is the point, 0.25 seconds, and what we have to do is we actually have to draw a tangent here. So I'm going to zoom in. Okay, just going to adjust this line a little. All right, so here we have a tangent. Let's identify 2 points on this tangent. So we have this point over here with the coordinates 0.5 and 0.9. And then we have another point over here. I'm just going to make the tangent longer. And we have another point over here of 0 and 0.325. The gradient is equal to the change in velocity over the change in time. So this will be 0.9 minus 0.325 divided by the change in time. This one is fairly easy. It's 0.5 minus 0. And if you punch this into your calculator, you will get a value of 1.15 meter per second squared. Okay, now in the second part, we have to calculate the resultant force acting on the ball at 0.25 seconds. Now remember Newton's second law. The resultant force is equal to the mass multiplied by the acceleration. So F net, in this case, will be equal to the mass multiplied by the acceleration. What is the mass? It is 0.015. What is the acceleration? We just calculated the acceleration. It's 1.15. If you multiply these two quantities together, you will get an answer of 0.017 Newton. And the direction will be towards the ground. Okay, so you will be awarded 1 mark here for showing that you knew how to draw a tangent, and another for having tried to find the gradient, even if you don't get the correct answer. So it's important to actually show your working. Let's have a look at part C. Use your answers in B to determine the drag on the ball at 0.25 seconds. How can we go about calculating the drag? We know that the acceleration is equal to, let's quickly see here, 1.15 meters per second squared. Okay. And we know that the resultant force is equal to 0.17 Newton. And we also know that the mass is equal to 0.015 kilograms. So what we are going to do now is we are going to calculate the weight of the ball. Now, the weight is equal to the mass times the gravitational acceleration. So in this case, it will be 0.015 multiplied by 9.81 which gives me 0.147 Newton towards the center of the Earth. Now we have to resolve the forces to determine the drag force. Okay, so the net force is equal to the weight minus drag. Now we want to rearrange this formula to make drag the subject. So it will become D is equal to the weight minus the net force or the resultant force. So that means the drag is equal to 0.147 newtons minus the net force, which is 0.017, 0.13 newton. And that's how you determine the drag.
Thank you for watching today's video on Smart Culture Education. If you found it helpful, don't forget to hit the like button and subscribe to the channel. And if you want to stay updated, tap the notification bell so you never miss our next lesson. See you in the next video.